Section 13.1, trig functions. So we started out the whole year of Algebra 2 talking about a function which has an input and an output. So that's the same for trig functions, and if you really get this part straight, you'll be in good shape. The fact that the input to a trig function, which will be a part of the domain, but I'm just going to write input right now, you actually give it, because you're not used to this, you give it an angle. That's what goes into the machine or the function. So you say sine of 30 degrees or cosine of 80 degrees. The input is an angle, and you're gonna see this theta symbol a lot for angle. And then the output, what comes out when you give it the sine, tangent, whatever of an angle goes in. Output is the ratio of two side lengths of a right triangle. So it's a fraction or a ratio of two side lengths of a right triangle, which is why we have to use the geometry that we've learned with right triangles. So the output is a ratio of two side lengths of a right triangle. And so we have this mnemonic that we use to remember which two side lengths it is depending on where the angle is, and that's called SOHCAH. So we have this mnemonic SO, S-O-H, CAH, C-A-H, TOA, T-O-A, SOHCAH, and that makes it easy to remember that when you want the sine, so I'll write those letters down here. When you want to take the sine of an angle, the two sides are going to be the opposite side over the hypotenuse. When you take C for cosine of an angle, the two side lengths you're talking about are adjacent side over hypotenuse. And when you take the tangent of an angle, the two side lengths you're referring to are the opposite side over the adjacent. So with a picture, let's be sure we're really clear on which sides we're talking about with those. So let's say we have, for example, remember we're always talking about a right triangle, so that has a 90-degree angle. The hypotenuse will always be sometimes people refer to it as the slanted side, the hypotenuse. It's the side that's opposite the right angle. So that's the hypotenuse, period. Now, as far as opposite, so the H in this mnemonic means hypotenuse. Now, as far as O and A, opposite, adjacent, depends where your angle is. So if I put the angle theta here, now my opposite side is the one that's furthest away. It's the side that doesn't make up the angle. This is the opposite side, and this is the adjacent side. The adjacent, even in the English language, means kind of next to, you're adjacent. So the adjacent side is the closest to the angle, the opposite side is far away. It doesn't even make up the angle. The two sides that make up the angle are here. Now, if I'm going to erase this now, because if I put my angle in a different place, if I'm referring to this angle over here, now this side is opposite, it's the furthest away, and this side is adjacent. And that's what the O and the A stand for in SOHCAH. But the hypotenuse will stay opposite the right angle. So so now we've defined sine, cosine, and tangent. There's others. There's three other functions. These are called, and these you would not have really covered at all in geometry. They're called the reciprocal functions. And so it's good to refer to them as their name, reciprocal, because that helps you remember where they come from. And all they are, the first one is called cosecant of theta, and cosecant is 1 over the sine of theta. So literally it's the reciprocal of the sine, and that's all you need to know about it for now. So that's cosecant. The secant of the angle is 1 over the cosine of the angle. That's secant. is the reciprocal of cosine, and the cotangent of the angle. This one's the easiest to remember because it goes along with tangent. So 1 over the tangent of the angle. So literally, when you're trying to find these, you usually find the sine, cosine, and tangent first, and then you flip it, and that's your answer. Because reciprocal means flip the fraction, and that's all you need to know about it right now. But you will need to remember that cosecant goes with sine and secant goes with cosine. And I'll give you a little tip. If you just remember one of them, then you know the other one, right? By process of elimination. So here's a little trick. Here's a little, it takes, and this isn't really true, but it takes a second to go to Costco. See it? It takes, not true at all. It takes a second to go to Costco. You know, the big, you know what Costco is. The groceries, big store. Okay. So because it's easy to mix these two up. This one people don't mix up because cotangent and tangent, it's obvious they're reciprocals. But these two people mix up, so now you won't mix it up. Just remember this one, and then you'll know that's the other one. Okay. So now let's get into the objective for what you need to do to show that you understand these functions. And so I'm going to try to remember to put a bullet by like a test objective when I can, or like what's written on the board. So here's on the board is our objective for the day. Evaluate the 6 trig functions. Evaluate 6 trig functions for theta. And that's what you'll see in your homework that you're practicing. So let's start with this one. First example. Let's say I give you this right triangle and I tell you these side lengths are 3 and 4. I tell you that the angle we're defining the functions for is that one, theta, and I want to evaluate the 6 trig functions for that right triangle. So you would say, I would start with the easy ones, the sine of theta, okay? Sine is opposite over hypotenuse by SOHCAHTOA, opposite over hypotenuse. So it is what? The opposite side is? The hypotenuse is? I don't know. Good. Someone said x. We don't know yet. So you could say x, or you could say, yeah, let's just say x. So we have to use Pythagorean theorem to be able to do these. So we have to go, unless you've memorized the Pythagorean triple, you already know it's 5 if you've memorized it. If not, you go a squared plus b squared equals c squared. Or leg squared plus leg squared equals hypotenuse squared. So this is 9 plus, I'll only show this, once, and then we'll go faster. 25. So now, does x equal plus or minus 5? Well, yes, but not in context, because we're looking for the length of a side length. So we use positive 5. So now we know that's 5. So the sine of the angle is 3/5. That's your answer. The output is the ratio of 2 sides. So you leave it 3/5. The cosine, so help me out here, cosine of the angle is, well, according to SOHCAHTOA, cosine is adjacent over hypotenuse. So what's the adjacent side? And what's the hypotenuse? Good. And tangent is opposite over adjacent. So the opposite side is 3, and the adjacent side is good. So those are the first 3. Now, we need all 6. So I'll put it right next to it, and you don't have to do much thinking. All you have to do is take the reciprocal. So what's the reciprocal of 3/5? 5/3. What's the reciprocal? So now I want secant, because that goes with cosine. Reciprocal is? Good, 5/4. And the cotangent of the angle is? Yes, 4/3. You simply go down and you take the reciprocal. Okay, so that's how you do those. And then I'm going to do one more different kind of example here, but that still shows that you know how to use these trig functions. So so last example is, let's say I have, if the cosine of theta is 7/10, what is the sine of theta? Question mark. If the cosine of theta is 7/10, what is the sine of theta? That's all that you'll be given. So in order to do this, you have to draw a picture. So I'm gonna make a right triangle. I'm making it face the other way because it doesn't matter. Okay, so this is how you would solve this. You got to make sense of what they're asking. So the given information is that the cosine of the angle is 7/10. So what is the sine? So where do you want to put theta? It doesn't matter where you put theta in this picture. So do you want to put it here or here? Here or here? Okay, okay. So let's put theta here. It doesn't really matter. So if that's where we're going to put theta, and the ratio of side lengths is adjacent over hypotenuse, the 7 has to go adjacent. So which of the two legs is adjacent to the angle? The one on the bottom. There's the 7. Adjacent hypotenuse is always, yeah, always the slanted side, so 10. So now looking at this picture, I want to find the sine of theta. That's all I need. I don't need all 6 trig functions. They just asked me for the sine of theta. So immediately you think SOHCAHTOA in your head, and so is sine is opposite over hypotenuse. So I'll even put O over H. So what is the opposite side? This is the opposite side of the angle. Well, I don't know, so I'll just call it, I'll label it because I don't know. So I'll go leg squared plus leg squared equals hypotenuse squared. That's Pythagorean theorem that you're going to need to use. So 49 plus x squared equals 100. X squared equals 51. So you want the square root of 51. And that's the length of your the other leg. And so now we can answer this ratio. The sine of the angle is the ratio of two side lengths. It's the opposite side, which is root 51. We just solved for that. The hypotenuse, we can see in the picture, is 10. So the answer is, I know it looks funny, but that is the answer. And if you can simplify the radical, if you see a perfect square under here, you should pull it out. Okay, you should simplify the radicals. We did a whole unit on radicals. So if this was like square root of 49, you should say 7. Okay, or if there's any perfect square, but 51, I believe, is prime. You can only break it down into 1 times 51, so we can't do anything, and that would be our answer.